welcome to the Marine Science Series, brought to you by Manatee Lagoon, an FPL Eco Discovery Center, and the Reef Institute. Our goal in this series is to take a deep dive into the world of marine science to learn how all living organisms are connected, and to learn a lot about the wonderful world that lies beneath the ocean's surface. Each lesson will be led by an educator such as myself from either Manatee Lagoon or the Reef Institute. My name is Ms. Schenker, and I'll be your educator for most of this marine science series. Are you ready to get started and learn a bit about marine science? Let's go. Today's lesson is on erosion. So the first thing I want you to do in today's lesson is take a look at the following images. These images are a before and an after. And I won't tell you much more than that for the time being, because I want you to take a look at both of these images and tell me what is different in the before versus in the after. I'll give you a hint. Count the houses in the before and in the after that are close to the beach. Or you may have already noticed the yellow arrow. In the before, the yellow arrow is pointing to a house. In the after, that house is no longer there. You may also notice in the before, the beach is much longer and has a lot more sand, whereas in the after, the water level is much higher and closer to the buildings. What do you think happened in between the before and the after of these photos to cause these changes? These photos were taken in 2017 before and after Hurricane Irma came through. So a hurricane came through and caused a lot of these changes. But what do you think moved the beach? What specific elements or processes moved those houses and moved the sand from those beaches? If you guessed erosion, you were right. The sand in this image and on that beach was moved by erosion. Erosion is when pieces of land are moved by wind, water, or ice. So in the case of that image, when the hurricane came through, the sand was moved by wind, by water, heavy rains, and by wind and water working together to make large waves that came and took that sand and pulled it out into the ocean, carrying sometimes structures such as houses that were on the beach with it. So erosion is when pieces of land are moved by wind, water, or ice. Now in today's experiment, and down here in South Florida, we're not going to touch too much on erosion via ice, because we don't really have any ice erosion down here. Most of our erosion is driven by water and by wind. So today, we are going to be conducting an experiment to test how wind and water can affect beach erosion. So think back to what a scientist is. Remember that a scientist is someone who observes the world around them, investigates, asks specific questions to try and learn more about that world, and then collects data or information in order to answer those questions. So today we are going to be scientists conducting an experiment to try and figure out how erosion works and what happens. So you will all be making up a hypothesis as to what is going to happen. And remember that a hypothesis is an educated guess, or a guess using information you already know. So if you have the follow along sheet for today's activity, go ahead and pull that out. If you don't, that's okay. All you need for today, if you're not going to do the experiment yourself, is a piece of paper and a writing utensil. So for today's experiment, we are using a paint pan, some sand, some water, some rocks, a spray bottle, and a fan, and we are going to test how wind and water can affect erosion. So let's go ahead and get started on our experiment. You can see here we have our pan with water on this side and sand on this side. So this sand represents our beach and the dunes on our beach, and the water represents the ocean. So on your follow along sheet or on your blank sheet of paper, take a hypothesis or an educated guess about what is going to happen when we turn a fan on that's behind the dunes. So if the wind is blowing this way, what do you think will happen in our experiment? What will happen to the sand if we turn on a fan, which represents the wind? Let's go ahead and turn on our fan and see what happens. Did anyone notice what happened to the sand when we turned on our fan, which represents the wind? You may have noticed that some of the sand blew into our water, blew from the dunes on the beach into the ocean. So wind is one of the elements that can cause erosion to occur. The wind is able to move the sand on a beach. And in some cases, if the wind is strong enough, it may blow the sand into the ocean, which can be carried away to a different location. So it's also important to note that erosion and weathering are two different processes. So you may have heard the term weathering before when referring to rocks being broken down, as well as erosion. And the difference is that in weathering, the land is moved far away from its source after being broken down. So in erosion, the land is staying somewhat close to its original source. In weathering, that land is being carried far away. All right, so make sure you have written down, or you can draw a picture of your observation of what happened when we added wind to our model or representation of a beach. Was your original hypothesis correct? Did you guess what would happen? Now I'm going to add a little bit more sand to our experiment. And I'm going to add a little bit more water. For the next step, which is going to be testing how water affects erosion. So if I have a spray bottle to represent the rain and I spray it on the beach, what do you think will happen to the sand? Make up your own hypothesis about what will happen to our sand if we use the spray bottle to represent rain. Now that you have your hypothesis, let's go ahead and test it. I'm going to spray our sand to represent heavy rains. Does anyone notice what's happening to our sand? You may notice that some of the sand is starting to run out into the water. So make sure, again, you are drawing or writing down your observations, collecting data on what's happening in our experiment. So when the rains are really heavy, it can wash the sand from the beach into the water, into the ocean. So we know that wind can cause erosion by pushing sand and carrying it into the water. Rain can cause erosion by wetting the sand and having it run down into the ocean. And now we're going to test what happens when wind and rain work together to create waves. So waves are water, but our biggest waves are usually caused by high winds, fast wind, such as during a hurricane, like you saw in those original photos from before and after Hurricane Irma. So now we're going to go ahead and we are going to make some waves in our model. What do you think will happen to the sand on the beach when we create waves? Let's find out. What happened to our beach when the waves came up? The waves eroded the beach and the sand into the ocean as well, didn't they? So waves can also come and carry sand and sediment into the water. So bigger waves are going to carry more sand than smaller waves. And we get very large waves during hurricanes when we have high winds, heavy rains, and large waves. So now I want you to think about what some of the negative effects of erosion could be. How can erosion negatively affect the area where it's occurring? Think about that while I set up for the second half of this experiment. So in the second half of this experiment, I'm going to push some of our sand back up to the beach, and then I'm going to use rocks to create a barrier between our beach and our water. So keep thinking about those negative effects of erosion, and we're going to come back to that after the second half of our experiment. So now we still have our beach and we still have our ocean. But what do you think will be different now that we've added these rocks into the mix? So I'm going to add some more dry sand on top of our beach, so that we can see what wind will do. So since the sand was already pretty wet, it didn't move too much. But what would you expect to happen to the sand now with these rocks here? You probably expect some of the sand to be trapped in the rocks before it could reach the ocean. So now let's test our rain again. So we're going to use our spray bottle to represent rain and see what is different. So make your hypothesis about what you think is going to happen to the sand now that we have these rocks here if there's heavy rain. What's different from the first time we did this experiment? You may have noticed that although the sand was still moving towards the water, it was getting caught up in the rocks and it wasn't able to make it all the way down to our ocean on this side. So these rocks were able to trap some of the sand and help slow or prevent some of the beach erosion in this case. For the last part of our experiment, we're going to do the waves with the rocks in place. So now make your final hypothesis about what you think is going to happen when we introduce waves to our beach with these rocks here. All right, let's go ahead and create some waves on our beach. What was different in this half of the experiment when we tried to see what would happen with erosion when waves occur versus the first half of the experiment? Maybe you noticed that, again, the sand was trapped by the rocks before it could wash into the ocean. And you may have also noticed that the rocks helped to break up some of the waves' energy, making the waves smaller by the time they reached our beach. So the waves still reached the beach and pulled the sand out, but not as much sand made it out to our ocean. And the rocks also helped to slow the waves down and make them smaller before they reached our beach. Great job, everyone. All right. So now I want you all to think back to those negative effects that erosion could have. What were some of your thoughts on how erosion can be a bad thing? What was one way you said that erosion could be a negative thing? Take a look at this image, which is another before and after. And notice some of the differences with these two images. You may notice how much more sand there is in the before, and how there's even some plants up near the building. Whereas in the after, there's almost no sand left to walk on, and that building looks dangerously close to the water. Erosion can negatively affect people in that if you have a property or a structure built really close to the beach, and that beach becomes eroded and that sand is carried away and the water gets higher, it could start to break down the foundation of your house, and it could carry that house away, just like in that first image we saw of the before and after Hurricane Irma. So erosion can be bad because it shrinks the amount of beach we have to walk on or to play on, and it could pose a threat to any buildings that are built too close to the beach. But erosion also impacts other animals and the habitat that is the beach and the dunes as well. So it doesn't just affect people. So if you think back to that second image we saw, you notice that there were some plants in the beginning of that photo, in the before, but in the after, those plants are gone and the beach is gone. So erosion can carry away some plants that are growing high up on the beach, and it reduces the amount of sand and the amount of beach that is present. So sea turtles who come up and lay their eggs on the beaches can be negatively affected because if there's less beach or a smaller area of beach, they may not be able to dig and lay a nest. Or if they already laid a nest and then those waves come up high, it could carry away their eggs and ruin their nest. So it can negatively affect animals that live on the beaches, as well as plants and sea turtles, and it also can negatively affect coral reefs. So think back to our experiment. How when the wind and the water and the rain eroded the sand, where did it carry that sand out to? Remember, erosion is when the land moves and doesn't go too far from its original source. So that sand is being carried just to that water right offshore of our beaches. And usually right offshore of our beaches, we have a lot of coral reefs. So corals need shallow water with lots of sunlight in order to be healthy. And if that sand that has eroded is carried out into the ocean and settles down on top of our coral reefs, it can smother the corals, reducing the amount of sunlight they can get and making it hard for them to feed and to breathe properly, which could make them sick and they may not survive if lots of sand settles on them from being eroded. So erosion can be a negative thing, but there are ways to help prevent erosion. Think back to that second part of the experiment when we added the rocks to our beach. Those rocks help to prevent the erosion or slow it down. So people will build structures such as seawalls or artificial reefs to help prevent or slow down beach erosion so that not as much sand will get carried off of our beaches. But the reason people make those artificial reefs to prevent erosion is because our coral reefs are also effective at helping to prevent or slow down erosion. So coral reefs help act as a physical barrier to break up waves that may be coming in. So if there's a large storm, the heavy rains may still wash sand into the ocean and the winds may blow it, but the waves will be broken up when they hit that coral reef, and they'll be smaller by the time they get to the beaches. So they help prevent large waves from crashing and carrying more sand away. And if you've ever heard of a mangrove, it's a type of tree we have here in Florida that have big, long, climbing roots that look like their fingers climbing in the water that are very tall. And those trees help to prevent erosion naturally as well. So those big roots that are matted and tangled up, they help to catch sand that would be blown into the water by wind. And they also help to catch any sand that may be washed into the water by the rain. So those mangroves, those trees, live right on the shoreline where the water meets the land. And so they're really good at breaking up the wave action and making those waves smaller so they can't get past the mangroves to pull more sand in to the water. And they help to prevent it from wind and rain as well. So there are a few ways that we can help prevent erosion through either natural ways, protecting mangroves and coral reefs, or by building artificial reefs as well. So as a review, erosion is when pieces of land are moved by wind, water, or ice. And in our experiment today, we tested how erosion may affect our beaches when we add wind or water. And then we tested how that may change when we add an artificial reef. We hope you learned a lot during this lesson. This lesson is a part of a multi-lesson series presented by Manatee Lagoon and the Reef Institute. We hope you all will follow along with us on other lessons to learn more about the fascinating world of marine science. Thanks for joining us. Bye.